So in this video, we're going to take a look at the Impacket script called GetNPUsers, which if you've not used it before, this is the one I'm talking about. And we're going to take quite an in-depth look at exactly how it works, because I'm conscious that a lot of people have used it on various CTF boxes, and it gives you results, like you get a user's password hash essentially, and you can then crack that. But I think a lot of people have no idea what it's actually doing, how it works, why it works. So we're going to take a look at that. And just to give you a rough idea of the format of the video, things we're going to cover, I'll do a quick demonstration of the tool running and being used and then cracking the password and stuff like that, so that, you know, if you haven't used the tool before, you've at least got some idea what we're talking about. We'll explain what makes a user account vulnerable to this script. I was going to call it an exploit, but it's not really an exploit because we're just doing normal Kerberos authentication stuff. This is all like supported stuff in the Kerberos protocol. And you'll see that we're going to look at the actual RFC briefly. Don't worry, not for long. And you'll see why we can use this script to actually get passwords from it. But again, there's nothing here that can be kind of patched and fixed really, unless they completely remove the option to disable pre-authentication. But I don't see them doing that anytime soon. And yeah, obviously I'm going to explain exactly what Kerberos pre-authentication is. And we're also going to look at a network packet capture in Wireshark of when the script runs, basically, so we can see exactly what's actually happening. And we'll take a quick look inside the script itself as well. So quite a few things to cover, but by the end of it, hopefully you'll have a good understanding of why the script works and what exactly it does. So let's start by just explaining the setup we've got here. We've got this workstation machine and then a domain controller as well with a couple of user accounts in it. Don't worry if you don't know anything about Active Directory and user accounts and LDAP attributes and all that stuff. I'll kind of explain the necessary bits as we go along. But I will be doing a separate video very soon just on all the basics of Active Directory, covering all this sort of stuff and a lot more. So yeah, this other machine is not a member of the domain or anything. This is a completely separate standalone machine. There's no kind of authorization between the two. So this is just like if you were running this on your machine and you were attacking this machine over here. So to get started, let's just run the script. And what we need to do, and I'm going to complain about the syntax here because I hate this syntax. What we have to do is specify the domain name. That is the name of this domain that we're attacking. And then just put a /, which is not obvious because if you look at the help text, it says that you need to specify domain /username and then optionally a password. Turns out the username is optional as well, but they don't document that anywhere. But anyway, someone figured that out because I saw an example of this the first time I looked into the script and realized that you can do this to search for all user accounts in the domain that are vulnerable, instead of having to specify a username, because sometimes you might not know the username. If we do DC IP address as well, just because I don't actually have DNS set up to point to this machine's IP. So if we do that, that should find any user accounts that are vulnerable, and it has. It's found one user account. Now, if we do that again, but with -request, we'll actually get the important parts from the TGT, and again, we'll explain what TGT is briefly in a minute. For our purposes, this is a password hash. We can get the user's password from this, but technically speaking, it's not actually just a password hash. In fact, I don't think the user's password is actually in there, but the password is used to encrypt this data. So if we know the value of some data in there, we can just run it through a word list password cracker, which is what we're going to do. And then once it decrypts a certain part of it in here that's always the same, then it knows that it's got the password correct, if that makes sense. I'm not too familiar with the password cracking side of it. I do need to look into that and fully understand that, but for the most part, I think we all just accept that you run something through a password cracker and it gives you a password. Later on, I will touch on exactly what I think is in here, but for now, let's just run it through Hashcat and prove that we can get the password from it. So I'm actually going to do this from my machine because for some reason it does not want to work on the VM. If we do mode 18200, that is just the mode that tells it this is what we're trying to crack, essentially an AS rep response. Again, we'll go through what that is in a minute. So that's just telling it exactly what it is that we're cracking. We'll do A0 because we just want to run through the word list in just straightforward order. We don't want it to do any kind of manipulation on the word list. And then we'll paste in the hash. So let's copy this. I think I already copied it, didn't I? I did. We'll stick some speech marks around it. Oh, actually, sorry, we need the whole thing, not just the hashed bit, because I think it's going to use these two options. This 23 tells it something about the format of this, and then I'm assuming this is the text that it's going to use as something that it can find in here, that once it decrypts it back to that, it knows it's got the right password, but I might be completely wrong on that front. And sorry we're starting this video off with so many like maybes and not explanations, but we'll just do that. Paste the whole thing in, there we go. And then yeah, we're just going to do the RockU word list, and this will run, and it shouldn't take too long because it's very simple password for it to find. And there we go, it's finished. We've got the password, which is password123, as you can see here. So that's how you can use this tool to get a user's password without ever knowing, well, we didn't even know their username to start with. This tool found the username for us, and then it found the password. So we're going to explain exactly how that works. And I think the first thing we should go through is what makes a user account vulnerable to this. Now, I can't remember if I already mentioned this, but I've never actually seen an account be vulnerable to this in the real world. Like there's never been a reason to enable this option that I've seen, and I've worked in Windows administration for about 8 years and in quite a few different organizations. That's not to say nobody ever uses it, but essentially if we go into users properties and we go into the account tab, there's a load of options here that we can set on the user account, and one of them is this option called do not require Kerberos pre-authentication. And that is what makes an account vulnerable to this. So if we go to another user account and we tick that option on them, click apply, and then we go back and we run the script again, just searching all accounts, you see now it finds that account as well, because that is now also vulnerable to this kind of attack. Like I said, I've never seen a reason to enable that. I would say most Windows admins don't even know that option exists. Like it's not something I've ever even heard anyone mention. So yeah, the chances of you finding this in the wild, I would say, are very slim, but you never know. So if we wanted to actually search the domain for any accounts that are vulnerable, like the Impacket script does, what would we do? If we look at this John Smith account who's got the option set, when we go into the attribute editor tab up here, which is basically just like a raw display of all of the LDAP attributes that populate all of these other tabs. So, you know, it's all formatted in a nice way here and in like an easy to use format. The attribute editor tab just gives you a look at the raw data. So if we look at a LDAP attribute called user account control, we can see that it's a number, but it has these kind of flags or options stored inside of it. Basically, I'm not going to go into exactly how that works, but if you're familiar with programming stuff, it's your usual just storing options in an integer using bits. But yeah, again, that's kind of beyond the scope of this video. All you need to know is that this number stores certain options. So we can see this user account, we've got the option don't expire password stored in here, and don't require pre-auth stored in here. So they were basically all of the things that we see in here. Password never expires, so that's the don't expire password thing. Don't require pre-auth is this Kerberos thing. If you're wondering why that one's not in there, that's actually done with permissions instead in the security tab. But yeah, the vast majority of the other options in here are all held in that user account control attribute. Now, things get a little bit messy when we want to actually do an LDAP search for these values, because unlike most values where it's just text and you can just do an LDAP search that looks really simple, where you just say URL equals whatever you want to search for, because of the way this is storing different options inside one number, we have to use a pretty ugly LDAP query. So all I'm going to say is just don't be put off by how weird this looks. Let's have a look at the Impacket script and you'll see how they're doing it, and that is basically the format that it has to be in. So let's go into here and then scripts and then GetNPUsers. Open that in Notepad++. Now, there's a lot to go through in here. I'm not going to go through the whole script, but the interesting bit for actually finding user accounts is this section here where we're doing an LDAP connection. LDAP is just the protocol that you use to query Active Directory domains, essentially. And once it's logged in, we do this LDAP query here. Now, this is why I say it gets pretty messy and looks really ugly, because this horrible looking number here, see, this is the attribute that we were just looking at. So this is the user account control attribute. We're saying find any object in the domain where the user account control attribute is set to this, and in Python, I believe, what that means is this first argument down here, and then the second time it sees it, it'll be the second argument down here. I've never used Python before, but just kind of judging by how this other stuff looks, that seems to be how it works, and it would make sense in the context of this LDAP query as well. So what this is doing, this weird number looking thing, the technical name would be a bitwise AND operation. You have like bitwise AND and you have a bitwise OR. But again, if you're not familiar with that stuff in programming, all you really need to know is that if you want to check a specific option being set in a number, which is, again, remember how this attribute works, you have to use this ugly looking thing and then put the number that corresponds to that. So this actually corresponds to a number, which is like 40,000 and something. I don't know what the number is off the top of my head, but we can look that up online. So let's do that now. We search for UF. See, I've already searched for it before. We just need to find the value of it, so let's go on this site that is always useful. We've got somewhere down here, there we go, UF don't require pre-auth, so this is the value that it needs to be. Again, I know this is all seeming really complicated, don't let this put you off LDAP queries normally. This is like the worst kind of LDAP query. Normally they're much more simple, and we'll cover all that in the Active Directory video, but I just want to demonstrate exactly how we can do this. So if we wanted to replicate this, we could just use any LDAP querying tool. We're going to use LDP, the built-in one in Microsoft Server operating systems. Connect to the local machine because it's running Active Directory. Just log on to make things simpler. And if we do a search, we're going to search the root of the domain. Again, we'll cover how these kind of weird domain name formats and stuff are constructed in the Active Directory video. We'll say we just want to bring back the username, which is called SAM account name. And we're going to do user account control because that's the attribute we want to search. And then we've got to do that weird number, which I'll look up in a second. And then we've got to say equals that number there, because that is just the special number that corresponds to that flag that we're looking for, which is the UF don't require pre-auth thing. So let's just grab the special bitwise and symbol thing here. And now hopefully if we run that, we get one account back, just like the Impacket script did, and it's the John Smith account. You can see he's got a username of J Smith. So that worked exactly the same as the Impacket script. So you can see that there's nothing sort of special or exploity going on there. It's just doing an LDAP query that you can do from any LDAP tool. So anyway, that covers the Impacket script and how it actually finds user accounts that are vulnerable. So what does it do when it finds a user account that's vulnerable? It builds all this stuff, which is basically just a Kerberos authentication request, and then it sends it to the server, which is what we're doing here, send receive to the Kerberos server. And then it gets a response in this ASREP format. And then to actually give us that password hash thing that we saw, which again isn't technically a password hash, it just looks at the encrypted part of the message and then outputs the cipher. So let's look at what that actually looks like in real terms of a Wireshark trace. And then as soon as we've done that, we'll explain exactly what Kerberos pre-authentication is and why it actually allows us to do these kind of attacks when it's disabled. So let's just do a filter for Kerberos only. And then we're going to run the GetNPUser script again to request so we actually get a ticket. And we'll see we get this thing sent off, which is the request, and then the server responds with this ASREP. Now you might have seen this technique that Impacket uses called ASREP roasting, which is not a very catchy name, is it? But that's what it's called because this response is just known as an ASREP, and the request is an ASREC. So in the request, we send out, this is all the stuff you just saw in the Impacket script. This is all the packet that it's building, basically. We send out this packet, and the only kind of important thing here is that the username that we're asking for, so somewhere in here, where is it gone? There we go. So the username that we're asking for a ticket for is J Smith, and the type of encryption we're asking for is this ARC4 format encryption. Now that's kind of important because by default, Kerberos will use a much stronger encryption type, but we're saying please send the encrypted data back in a much easier to crack format, basically. That's if you look at Google on that format, it's basically just well known as being a pretty weak encryption routine. So what does the server send back? In this case, because this user is vulnerable, it sends us back a Kerberos ticket and this encrypted part, which again, if you remember here, it's looking at enc part cipher. So if we look here, we've got enc part and then cipher inside it. And you'll see that this data here, this 0535 blah, 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 is exactly the same as what Impacket spat out as the end result. So 0535 blah, blah, blah. So this data is basically all we're after. And the reason we're after it is because if we look at the RFC, when we go to the format of this message, so ASREP, so this is what we want, generation of ASREP. Actually, no, we want the format of it, sorry, that's just the description of it. We want to actually see the implementation of it. And this is a really confusing RFC because they call the same thing different names in different sections. So you see up there, they were calling it ASREP, but now it's called a KDC rep. It gets very confusing. But a KDC rep has ASREP or TGS rep as a part of it. It's a really confusing RFC to read through, but essentially we get the encrypted part, which is here, that enc part section. So that's what we're looking at, and this can be one of these two types, but then they both end up actually being the same type. Again, super confusing, but it ends up being this. So this is all the data that is coming back in this part, in this ciphertext. And the important thing for us is that this was encrypted using the user's password. Now, like I said before, I'm not too clued up on exactly how the the password cracking side of it works. I have been looking at the hashcat source code and trying to figure out exactly how it does this, but it's all in C and C++, and I'm not too good with that. So I've tried to follow it through as much as I can. I'm normally not too bad with C++ stuff, but I'm struggling with that one. So I've asked on the forums, and we'll see if anyone can kind of explain it in greater detail, which if I do get an explanation to that, I'll leave it down in the comments. But yeah, for now, my understanding is simply that this part, this whole section is encrypted with the user's password, and then a password cracker like Hashcat can come along with a word list and just keep trying. It essentially is brute force until it gets the right password. But again, I'm not sure on exactly how it knows when it's got the right password. Either way, let's now explain what is kind of the most important part of this video. And maybe I should have explained this first, but I feel like it wouldn't have made any sense without going through all this stuff first. And that is what pre-authentication is and how it stops this attack. Because remember, the whole reason this attack is possible is because pre-authentication is disabled. So what happens when pre-authentication is enabled? Let's have a look at that first of all. So if we try and do this for a user account that doesn't have pre-authentication disabled, it prompts us for a password for a start. Sorry, I meant to capture that. Let's just do that again. Here we go. So what happens now is we send the same request, obviously, for a different username this time though, but then the server responds with this error instead. So it says error pre-auth required. So what actually is pre-auth, and why does having it enabled stop us from being able to do any kind of attack? Well, I mean, first of all, you saw that if it's not enabled, we just get an error back, so that kind of halts the attack in its tracks straight away. But even if we didn't get an error back, the problem is with pre-auth enabled, the server is expecting us to encrypt the current time and send it with our request, and then the server will decrypt that with the user's password. So that's the key thing there that I forgot to mention, is that when we encrypt the current time, it has to be encrypted using the user's password. So we obviously have to know the password for this to work, and obviously at this point we don't know the user's password. That's the whole problem we're trying to get around. So if we do know the user's password, we can encrypt the current time and then send it to the server with this request, which will be in this PA data section, I assume. I think this is pre-authentication data. When the server receives it, it will decrypt the current time using the user's password, because obviously the server knows the user's password. It's in the Active Directory database. And it will say, is the current time roughly the same as my current time? If it is, then we know that this request is actually a legitimate request that's going through right now and not a replay attack, because with a replay attack, you could capture all of these packets like we're doing here and then just send them again later to the server. If there was no sort of timestamp involved, no encrypted timestamp involved using the user's password, then maybe you could just keep sending that data over and over again and the server would keep thinking it's legitimate. But with pre-authentication enabled, you have to encrypt the current time to prove that this message is legitimate. And so it proves that you've got the password, and it also proves that the request is actually happening like right now and not being replayed later. So if you've ever tried to authenticate with Kerberos and got an error saying something like clock skew incorrect or something weird like that, that's because the time that your computer is sending with this authentication request is not the same as the server's. I think it has to be within 5 minutes by default on Active Directory setups anyway. It might be different on other Kerberos systems, but if it's not within 5 minutes of the server's clock, then it will reject it, because it basically just assumes this could be a replay attack. So that's why you get that error. And yeah, that's pretty much it. I feel like I've not done a particularly good job explaining some of these parts and kind of just waffled on as I usually do. But that's pretty much it. So let's give a quick summary just in case you got lost along the way anywhere there. So to start with, the script just finds user accounts by searching Active Directory for any user accounts where that do not require Kerberos pre-authentication option is enabled, which again, I've never actually seen used in real life. It does that by doing that LDAP filter that we looked at, which searches the user account control attribute. When it finds a user account, it will then send a authentication request, because it knows that the server is not going to reject this and say that it needs pre-auth now. So it'll send an authentication request to the Kerberos server. It will say, please send me back the data for this user account and encrypt it in this format. Now, you might think straight away that's just a terrible idea, but why is that even an option? Why can anyone just request data for any other user account that essentially gives them the user's password? In the RFC document, they do say, I'm not going to be able to find it now, but they do say somewhere basically, this is not a problem because nobody else can use the data, because it's encrypted with the user's password. Unfortunately, in reality, that's not the case, because as you've seen, we can crack the encrypted data offline. So yeah, going back to the summary, sorry, I got sidetracked again. So it sends a request saying, for this user account, send me back some encrypted data. Again, we'll get into what TGTs are in another video, but send me back some encrypted data that it was encrypted with this user's password. The server sends that back. Obviously, we just got an error here, but in the other one where it worked, the server sends the data back, encrypted with the user's password. We can then take some of that data that's encrypted with the user's password and then use that to derive the user's password from it. So hopefully that made some kind of sense, and hopefully now you've got a rough idea of what this is all doing. The Kerberos stuff, like I say, there's kind of too much to Kerberos and TGTs and all that stuff to be explaining all of that in this video as well. So I appreciate some of that might not have made sense, but for a TGT, you can just think of it as a kind of an authentication token that a user account can then use to authenticate with other services. So a TGT is what kind of the first step when you log on or authenticate with Kerberos, which is what's used in the majority of Active Directory authentication. It goes to the Kerberos server, which will be an Active Directory domain controller in this case, It asks for a TGT, which contains a load of information about the user, and it should only get the TGT if it has the correct username and password. But as we're seeing here with pre-authentication disabled, you can actually get the TGT without that. So that is the long story short version, although I think we're way past that point, aren't we? And yeah, hopefully you learned something. If I've just made things more confusing, I'm sorry, but hopefully that explained a little bit. And if you've got any questions in particular about this or anything that you want me to cover in the Active Directory video that I'm going to be doing, which will be a lot more straightforward than this. This was obviously quite a sort of deep technical dive into some network stuff and some RFCs and some data packet formats and all sorts of stuff. The Active Directory one will be a lot more straightforward. I'll just be explaining exactly what all this stuff is, how you can construct object paths, how you can look at permissions. We'll explain DNS integration, group policy, just a lot of sort of fundamental Active Directory stuff that is good to know if you're attacking an Active Directory machine, or domain, sorry. And yeah, we'll just cover kind of all the basics that you need to know. So yeah, as always, if you can leave some feedback in the comments, that would be much appreciated. And if there's any requests that you've got for things you want to see me include in the Active Directory video, mention them as well, or any future topics you want me to cover, mention those, and I'll do my best.